Alright, so we are starting chapter 7, and the first thing we're going to be talking about is direct variation and inverse variation. And you have actually seen direct variation, you'll realize that in a little bit. But what we want to talk about is what is the big difference between direct variation and inverse variation. So dV is direct variation, IV is inverse variation. And the first thing you need to know is that x is considered the input, it's our independent variable. And y is our output, it's our dependent variable, and y depends on x. Okay, so the first thing we're just going to talk about is direct variation. So in direct variation is a ratio, and it's the ratio of the output, so it's a ratio of y to the input of x. And you're always, when you have this ratio of y over x, you're always going to get a constant, some same amount. And so for constant, I'm going to be using the letter K. Sometimes they use the letter A, like an apple. Sometimes they use the letter M. A lot of books do use the letter K for constant, okay? So the idea is, in direct variation, one variable increases, so for instance, as x increases, then the other variable also increases so that the ratio between the two can be the same. So for instance, if I just start comparing, this y and x to this y and x to this y and x, then what happens is, if I use this formula that I just gave you, k equals y over x, then if I take, for this one, -5 over -1, or for this one, take y over x or y over x, then I always get the same amount. I always get 5, and that, as it turns out, is what my k is. Okay? And then you can go back and I'll show the other equation for direct variation, and it's this. It's y equals kx. And you actually have seen this before. It's similar to y equals mx plus b, but instead of m, they use k, and the y-intercept is always 0. So that's why 0, 0 shows up in here. So when I look at this equation, it's direct variation, because when I compare the ratio of the y to the x's, I always get the same constant amount. I always get 5. And then I can write the equation for my direct variation, and again, an equation is y equals, and then the other stuff. So this would be y equals 5x. So it is just a line, and so that's why I said you had seen this before. It's a line, but the y-intercept is 0. And the y-intercept is when x is 0, and so y is 0. So you're always going to see 0, 0 in direct variation. If I start to put a slope in there, then this taking and the ratio of y over x isn't going to happen. You're not going to always get the same amount because you've got a y-intercept affecting it. Hopefully that makes sense. So what are some examples of direct variation? Well, anytime you get paid. So you get paid $8 an hour. So the amount you get paid varies directly with how many hours you worked. So first of all, which one is which is x and which is y? So the way to ask yourself this question is, what depends on what? So the amount you get paid this depends on the number of hours you work. So for instance, if you work 1 hour, you get $8. If you work 2 hours, $16. If you work 3, $24. And if you work 4, that's $32. As x gets bigger, y gets bigger. And this constant amount is the fact that it's changing by the same amount every single time. Okay? Because I'm basically just adding 8. But again, the constant is this ratio of y over x. So if you take 8 divided by 1, you get 8. If you take 16 divided by 2, you get 8. If you take 24 divided by 3, k is 8. If you take 32 divided by 4, k is 8. So in the end, k is 8. And if I were to write the equation that represents this situation, an equation is y equals 8x. So the two equations. One equation is the ratio one that helps you find k, and the other equation is the equation that represents the entire situation. All right? So you drive 60 miles per hour, and the distance you drive varies directly with how long or the time that you drove. So this is direct variation. So what's what? Well, basically, the distance you drive depends on how long you drive or the time. So if you're driving 60 miles per hour, cruise control is set. If you drive 1 hour, there's 60 miles. If you drive 2 hours, 120, 3, 180, 4, 240. So what's the equation? Well, again, there's this constant ratio. K is y over x. So 60 over 1, or 120 over 2, or 180 over 3, or 240 over 4. They always give me the same amount for k. K is 60. And then once I know k, I can write the equation that represents this direct variation, which is y equals 60x. And again, this whole idea about 0, 0. 0, 0 could fit in here technically. If you work, I don't know, let's just put it here. If you work 0 hours, then you're getting no money. Or if you don't drive at any speed, if you don't drive at all, so 1 minute, 2 minutes, if you drive no minutes, you've gone no miles. Okay, so you can kind of see how 0, 0 would still fit in these. So that's direct variation. Again, direct variation is a ratio between y and x. This ratio helps you find your constant, but then this is the equation. When they say write the equation that represents direct variation, this is what they're looking for. An equation is y equals. So let's go to inverse variation. So in inverse variation, there's another thing happening between y and x, but it's the product, and product is multiplying of the output and the input. So now to get k, I'm going to multiply y and x instead of dividing y and x. And when you multiply y and x, you're always going to get the constant. So if you're looking for the constant, this is how you do it. But again, when they want the equation for the inverse variation, now I need it to be y equals, and so I would just move x to the other side by dividing. So it's y equals k over x. So what's going to happen here is when you look at a set of numbers is as one variable increases, the other one decreases. Okay, and it could even be that this one's increasing if you go this way, and that means this one's decreasing that way. Okay, so the idea, this is inverse variation. One way I can see this is, again, this is increasing left to right, this is decreasing left to right. So that's kind of the first inclination that it's inverse variation. But how I verify it is I look to see if the constant between y and x is always a product. So if I multiply y and x, do I always get the same number? So if I multiply 2 and negative 12, that's negative 24. Or 4 and negative 6, that's negative 24. Negative 24, negative 24. So by going through each x and y and doing that product, I can see that k is negative 24. But when they want me to write the equation, again, I write the equation in the form y equals. So I just take y, and it's going to be negative 24 over x. All right? All right, so let's go and look at some examples. So the number of slices of pizza you get varies inversely with how many people there are to feed. So if there are 16 slices to a pizza, then, so first, what's x and what's y? Well, this is all about how many slices of pizza a person gets. So the number of slices you get, that depends on how many people there are. So for instance, if there's only one person, that person gets all 16 slices. If there are 2 people, then each person gets 8. I'm going to skip 3 because it's not a nice number. I'm going to go to 4. If there are 4 people, each gets 4 slices. And if there are 8 people, they each get 2 slices. So you can see as x is increasing, y is decreasing. So what's the constant? Well, you can go back to your formula that the constant is when you take your y and you multiply the x. So 1 times 6, there's 16. Multiply, you get 16. Multiply, you get 16. Multiply, you get 16. So k is 16. But when they want you to write the equation, they want you to use this version, y equals k over x. So it's going to be y equals 16 over x. All right? Let's look at another one. This is another driving analogy. So Colorado Springs is approximately 70 miles from Aurora. The time it takes you to drive to Colorado Springs varies inversely with the speed that you drive. So what depends on what? Well, this time over here they were comparing your distance and your time. So this is comparing your speed to your time. So what depends on what? Well, how long it takes you to drive there, the time it takes you to get there, that depends on how fast you go. So if you drive really slow, it's going to take you longer to get there because the mileage is set at 70 miles. But if you drive really fast, then it won't take you very long to get there. So your time depends on your speed because it's a set distance. So for instance, if you drive 70 miles per hour, you're there in 1 hour. I'm going to work with numbers that work well with this problem. So if you drive 35 miles per hour, then it's going to take you 2 hours to get there. Or if you drive 10 miles per hour, it's going to take you 7 miles to get there. Or if you drive 7 miles per hour, which we would never do, maybe you're running really fast or you're biking really slow, it'll take you 10 hours to get there. So again, what's your K? K is when you multiply y and x. So if we multiply, we're always getting 70. And then you can write your equation, y equals k over x. So where does 0, 0 fit in there? Well, this is kind of going back to that, almost like that Cookie Monster thing that you ask on Siri. So what happens if you do put 0, 0 in there? Well, if there are no slices of pizza, no people even need to bother showing up, okay? Or if you never drive, if you're not even going in the car, you're never going to get anywhere. No time's going to go by, okay? And if you think about it, the reason why 0, 0 is not going to work is because, you know, when you put 0 in for x, we can't divide by 0. So that's why 0, 0 is never going to appear here, but it can appear here, all right? So that's the first part of direct variation and inverse variation. Let's take a look at the graphs.